Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x plus 5 times x minus 2. For the math knowledge question, first off, you need to draw a triangle, and we have angle R, E, and T. And they tell us that E and T are congruent to each other, and that R is 94 degrees. We know that these have to all add up to 180 degrees, and since E equals T, I can actually say 2E, or you could say 2T, plus 94 equals 180. And then if you subtract 2E, it's going to equal 86. And so E equals 43. So there would be the measure of angle E. We're looking at lesson 11 today, dealing with continuity and then left and right hand limits. So this is a calculus concept. You haven't really had much calculus, even though we've been in calculus for a couple of weeks now. This is actually a calculus concept. So hopefully you'll understand continuity, left and right hand limits. Limits do not go away. You have to practice at these. So if you don't get them right off, you really need to keep practicing, keep practicing. You will get them, but some people, they don't come automatically. You have to sit there and really work at them. And then some people, they get them and they look at their classmates and don't understand what the problem is. It just depends on how you think through things. Everyone can handle them. It just takes a little while for some people. All right, so looking at continuity. So continuity, continuous, you see how they have the same base word. If you have a continuous function on an interval between x values a and b, and if it's defined for all of those x values between a and b, and a small change in x does not produce a sudden jump in the values of y, then that is going to be a continuous function. Basically, if you take your pencil and you draw something from A to B and it never gets picked up, that's a continuous function. A function that is not continuous at any value of x is going to have a discontinuity at that value of x, or it's going to be discontinuous. And I've got some pictures of some functions that are not continuous. They are discontinuous. All right, so right here, this has a discontinuity at this value of a, because we keep increasing, but at a it does not exist. There's an asymptote. Once we get on the other side of a, it starts decreasing. So if you have a vertical asymptote, that would be a discontinuity. Same thing on this one. We make a big jump across the vertical asymptote. That's not continuous. Here, it is not continuous because we jump from whatever this value is up to here. This one is not continuous because there's a hole at D. And then E is not continuous because there's a hole. Even though there is a value at E, it is not continuous because we made a little hole there. So those are the basic functions that are not going to be continuous that you'll see most often, that type of function. So vertical asymptote, I just went over that term on the last slide. I used it, but I didn't tell you what it is. It's a vertical line that you approach, but you never touch it. The graph will never actually touch the vertical asymptote. So looking here, there are two vertical asymptotes that are shown. On this one, it's like a volcano because they're approaching it from both sides, but we will never actually touch that value. And on B, they're approaching it from the left and from the right at different values. One is going up to positive infinity, and this one is going down to negative infinity. And so those are both vertical asymptotes. And that's what you'll do at one. You'll either jump or you'll make a volcano. So now looking at limits. The study of calculus is based on a concept called the limit of a function. The limit of a function is going to be the value of the function approaches as x gets very close to some designated number. So if I'm drawing a graph, and I'm just looking at a line here, and we'll say that we're looking at this point. We'll say this is 10 and this is 5. I know it's not drawn to scale. That's okay. We are looking at the limit as our x value approaches 5. Well, as we get close to 5, what is the value of our function? The value of the function is going to be the y value. So when our x is 5, what is our y value really close to? On this one, it actually isn't close to, it's exactly 10. So that's how you're going to do a limit on a line. But they're not always going to be lines. And we'll have some examples that we'll go through. So here they drew a little bit more complex graph over here on the right. This is kind of like a line like I was just showing you on the left. So at 3, as the limit approaches 3, our y value is approaching 20. Do y'all see how that would work? They drew the vertical line, the dotted line, so that you could tell what the x and y values matched up with. For 4, the limit approaches 22. Do y'all see how it's 22 at 4? Okay, at 5, we've got an issue because there's a big jump. So the limit as x approaches from the left side, what is it getting closer and closer to? Well, it's 29, but 30 is actually what the limit as it approaches from the left is, because that's the hole that it approaches. If you come from the right, the limit approaches 40. And so if you're coming from the left, the limit would be 30. And if you're coming from the right, the limit would be 40. And so it is possible that you have two different left and right hand limits. If it asks for the limit at 5, it does not exist because the left and right hand limits are different. So you can approach it from the left or from the right or at 5, and it'll tell you what it's wanting you to find. So the limit of x as it approaches some number a from the left or the right is the number that the function gets closer and closer to as your x value gets closer and closer to a. When we are discussing limits, it does not matter what the value of the function is when x equals a. Like, we don't care if it actually has a value, we just want to know what it's getting close to. So I'm going to go back to the graph we were just looking at. If you look at this graph on the right, there isn't a function value at 5 because there's an open hole here and here. So the f of 5 does not exist because there's no value. Now, if it were dark here, for instance, then it would equal 40. Or if it were dark here, then it would equal 30. But since it's not, it does not exist. But that's okay when we're looking at limits. It's okay for the function value to not exist and still have a limit. So let's look at this one. Given the graph of f, we want to estimate the limit of our function as x approaches 3, and then you see this little plus sign, 3 and the negative. You see those? This means from the right. Because of that little plus sign there. This little minus sign means from the left. So you're going to start either to the left or to the right of 3, depending on what it's asking for. So let's look. Here's 3. So the first one says approach 3 from the right. So start on the right side and approach it, approach it, approach it, approach it. What are you getting close to when you get to 3? The y value you're getting close to is 2. So this is going to be 2. The limit as you approach from the right is 2. Now we're going to approach from the left. If you come on the left side of your function and you approach this way, what value are we getting closer and closer to? We are approaching this point here, which is 1. So that one is a 1. Do you notice how the left and the right hand are two different values? because there's a big jump here, and that's okay. If it had asked for the limit at 3, so I'm going to go ahead and show you what the notation looks like. So this would be A if you wrote it in math format. The limit as x approaches 3 from the right of this function would be 2. For part B, the limit as x approaches 3 negative of f of x from the left would be 1. That's what we just found. This is a new one. If you're looking only at 3, you would write it as the limit as x approaches 3. Nothing would be right here. Just as it approaches 3 of this function, do the left and the right hand limits match up? Since they don't match up, it does not exist. They didn't ask us for that, but that's how you would go about finding it. Okay, so now let's look at as x approaches 1 from, what does this little minus sign mean? From the left. Okay, so as we approach 1 from the left, start over on the left side of 1 and start moving. And we're getting closer and closer to what y value? Closer and closer to 1. So that value is 1. Now we want to approach from 1 coming from the right because it's a plus sign. So here's 1. If we start to the right of that and we approach it, we're getting close to what y value as we get closer to 1. The y value is a 2 here. So this one would equal 2. On graphs like this, go with whole numbers, even if it looks like it might be 1.1 or something, unless they're showing you tick marks in here, go with whole numbers. Don't make it more complicated than it needs to be. Okay, so let's look at this one. We want to estimate the limit, and y'all may not be able to see it here. There's a plus sign. And there's a minus sign. It may be hard to see on the computer. So we're looking at 3, which is right here. Okay, and we want to know as it approaches from the left and from the right. From the right and from the left. So 3 hits right here. What y value is over here? 40. And as we approach from the right, what is it approaching? Is it approaching that y value? It is. So this one would equal 40. And also, as you approach from the left, it's still approaching that same 40. So it would equal 40. On a continuous function that doesn't have a jump, the left and the right hand limits should equal. So on this one, if we were looking at just the limit as x approaches 3 of our function, it would also equal 40 because the left and the right hand limits are both matching up. Okay? So now we want to sketch this graph and then find the limits. And again, it may be kind of hard to tell. This says plus and this is a minus. So first we want to graph our function. So it equals 1 when x is greater than or equal to 0. And it equals -1 when it's less than 0. So it's an open circle there. So that's the graph of this function. And it wants to know the limit as we approach 0 from the right. So coming from the right, as we get closer and closer to 0, what value are we approaching for our y value? The y value is a 1. So this would equal 1. As we approach 0 from the left, what y value are we approaching? We're approaching -1. Now, if I ask for the limit as x approached 0, not from the left or the right, just as x approached 0, what would that limit be? Hopefully you would say does not exist, because our left and our right hand limits are not the same thing. Anytime your left and right hand limits aren't the same thing, then you're going to want to say that at that specific number, it does not exist. All right, so your homework is 1 through 25, so make sure that you do that tonight so we can go over your questions tomorrow. I have found a website to help you with two-sided limits, if you want to look at them. This first part, you could graph them on your graphing calculator, 1 through 15, if you wanted. Those probably aren't the best ones to use. Same thing with these. I wouldn't try those. I would look more at number 17, where it gives you the graph. Number 18, where it also gives you the graph. And number 19, where it gives you the graph here. Number 20 gives you the graph, and then it gives you the answers to all of them and solutions to the first several. And then if you look, it doesn't go past number 15. So it just gives you answers to the first, to the ones that have the graph. So I would look at number, again, number 17. Y'all can pause the video and practice those if you want. And then you can look at number 18 if you want to pause the video and go through those. And then number 19. And then number 20. And then I'll go to the answers again. Those are the answers for 17 through 20. And if y'all look up here, this is the website that you're welcome to go to if you would rather. But hopefully that'll give you some more practice. You do have some homework questions that practice it a little bit, but sometimes y'all need more practice on these. So this is a great resource for y'all to use if you would like. Hopefully that'll help you out with some limits.